Math 155. In this lecture video, let's take a look at 14.4 and 14.5 integrated review, simplifying expression using what we so-called the product rule for exponents. So before I introduce this product rule down here, let us take a look at the way how we're supposed to look at the exponents. So here I wrote 2 to the third. 2 to the third, when we're having an exponent, 2 to the third means 2 times itself 3 times. 2 is called the base. All right, 2 is called the base, and the 3 is called the exponent. So a lot of times, what I like to ask students is, when you see 2 to the third, how do you know? How do you know 2 is the base? What determines 2 as the base? Well, the answer to that is because the exponent 3 is actually sitting on top of the 2. All right, so in that case, okay, because like the base 2 is like a 2 is the base sounds like a basement. Okay, basement is always located below the first floor, so that means you must solve the exponent first in order to determine what the base is. Okay, so that changed the way how you look at exponent. When we read 2 to the third, in order to determine what is the base, we got to see where the exponent is sitting on. So the exponent 3 is actually sitting on top of the 2, so that makes 2 the base. So here I got negative 2 to the 4th power versus negative 2 to the 4th power. Well, what's the difference, when I write it 2 different ways? Well, the difference is actually not just the answers are different, is who the exponent is sitting on. If you look at this exponent 4 is actually sitting on top of the 2, not negative 2. So that actually makes 2 the base. So that means who times itself 4 times here is the 2 times itself 4 times. So what do I do with this negative? This negative up front actually means negative 1 times. Okay, so this problem, negative 2 to the 4th, actually means negative 1 times 2 times itself 4 times. Therefore, my answer is negative 16. Okay, compared to the other side, this exponent 4 is sitting on top of the entire negative 2. That's why there is a parenthesis there. Therefore, negative 2 is the base. So if negative 2 is the base, then it's going to be negative 2 times itself 4 times. I'm going to purposely write them in the parenthesis so you can see it's the negative 2 times itself 4 times. Therefore, my answer will be positive 16. So it's not just one answer is positive, one answer is negative. It has a lot to do with where who the exponent is sitting on top of. If it's sitting on top of the 2, 2 is the base. If it's on top of the entire negative 2, that's why there's a parenthesis there. Okay, then negative 2 is the base. So as you can see, when a negative number here, okay, is in the parenthesis is raised into an even power, then my answer will always be positive. Okay, because I have even number of negatives that are being multiplied. Therefore, the answer is positive. So if I have a negative number inside an odd exponent, okay, in the parentheses raised into an odd exponent, my answer will always be negative because I have odd number negative being multiplied. So that one extra odd negative, okay, is what made my answer negative when I multiply or divide. All right, so keep this concept in mind. We will need it in other videos. So what is this thing called the product rule? Okay, product rule for exponent says for any real number a to the n power times the base that are the same but raising to a different exponent. As you can recall, multiplication between anything only is actually one term. So this exponent rule only applies for one terms. So when the base are the same and the base are multiplying, what do we do with the exponent? We simply add them. Okay, so why do we add them? So here I wrote a small, this example is a little bit too small. Let me make it, I can't make it bigger. So what I'm going to do is I'm going to write it here. Why do we add the exponents? Well, look at this 2 to the third. 2 to the third means 2 times itself 3 times. Times by another 2 to the fourth. 2 to the fourth power means 2 times itself. 2 times itself 4 more times. So what we see here is there are 7 2's being multiplied. So that's why the answer is 2 to the 7th power. So that means 2 to the 7th power means I got 7 2's being multiplied. So that's why we simply add the exponents. All right. So be careful, don't say 2 times 2 is 4. If you say the answer is 4 to the 7, that would not make any sense because you are saying the base now become 4. Well, the base is actually 2, so it shouldn't become 4. Become 4. All right. So let's take a look at a couple of examples. Then I'm going to do these ones right here. Just kind of practice how we're supposed to look at the exponent. All right, so last time we said that anything to the 0 power is always going to be 1. So this x to the 0 power is really just 1. So x squared times 1 is still going to be x squared. All right, so here I see x to the 5th times x to the 9 times x to the 7. I see this is all 1 terms. Okay, all the bases are the same and they're all multiplying. So we simply add the exponent. So you don't have to write all the adding. If you know the rule, you just simply add all the exponent. 5 plus 9 plus 7. So that means this is x to the 21 power. So what that means is, here I got 5x in the front being multiplied. Here I got 9 of them being multiplied. I'm just not writing all of them out. On the back, there's 7 more x's being multiplied. So if you write everything out, there should be 21 of those x's being multiplied. So that's the reason why we add the exponents. Okay. All right. So let's practice. Okay. Let's train our eyes a little bit on how we should look at the exponent. So find the exponent first and see who the exponents sit on. So this exponent 0 is sitting on top of the 5. So anything to the 0 power is always going to be 1. Okay. All right. My exponent 0 here is sitting on top of the entire 6a. So anything to 0 power is always 1. Now this one is a little bit different. This negative sign is actually on the outside the parentheses. So that means this exponent 0 is only sitting on top of the 6a. So 6a to the 0 power is 1. So this negative sign up front means negative 1 times. So that will make my answer negative because this is negative sign up front. All right. So what made my answer negative? Well, if I have a negative 1 times in front of it, it can make my answer negative, just like this negative 2 to the 4th power. Or if I have a negative, okay, if I have a negative number in the parentheses raised to the I power, then my answer is negative. Okay, so if we go back to the 0 exponent, this explanation of number lines here, negative exponent does not make my answer negative. It only give me answer that will be between 0 to 1. All right, so let's just kind of play with this a little bit. This is 6a to the 0 power. 6a to the 0 power. So if you focus on this exponent 0, it's actually sitting on top of the a, because 6a to the 0 power means 6 times a to the 0 power. So a to the 0 power is 1. Multiplication sign is in the front. This 6 is actually 6 to the 1st power. So that will still be 6. So 6 times 1 is going to be 6. All right. So if I come back to this problem, and this time I'm going to write negative 6a in the parenthesis, holding to 0 power. Then the answer will become positive 1. Because this time, for example, this 0 now is sitting on top of the entire base, negative 6a. So anything to 0 power is 1. So there is a big difference, have the negative sign in front of it versus is inside of it. Okay? Because then the exponent, it changes. Because this negative sign here actually means negative 1 times 6a whole into 0 power. So this negative 1 actually has exponent 1. Okay? But when it's inside of it, then the exponent you look at is the one on the very outside. All right? So just a quick lecture video on the exponent rules and how we're supposed to look at exponents, which is always find the exponent first in order to determine what the base is. All right, that will conclude this lecture video. Thank you for watching.